Okay, so basic differentiation rules. So you just learned the long way, the limit process, and you just need to know like some of these symbols they use in the textbook. Like the big long limit formula we learned last time. That's f prime of x. This f prime thing, when they write it like that, that means derivative. You know, that means derivative. And keep in mind, a derivative is just a slope. It gives you a formula so you can find slope of different functions. So f prime, that's one way you say you're finding derivative. In the book now, you're going to start seeing other forms. Like, if you have an equation that's y equals something, and then they say find the derivative of it, then you can write y prime. Another way, to instead of writing f of x, f prime of x, they say y prime. That's another way to write a derivative. Just so you know, it's just like another way. Instead of writing f of x, f prime of x. Now, if you have a y equation, the derivative of that's y prime. Another way you see it in the text is d over d of x. D stands for derivative. So this just means that, like if you want to read this just means derivative. Derivative with, they say with respect to. They say derivative with respect to x. Because you know, like formulas have x's in them, so you're finding the derivative with respect to x. That's again just another way you see it. If they write in your text you're doing d dx, it means you're finding the derivative. Another one you see, I'll just write off to the side so I don't take up so much room. Another way they write it is dy dx. Because you have a function y, and it says you're finding the derivative of y with respect to x. Derivative of y, you know, like your y function with respect to x. That's how they read these things. So just so you know, like different notations, how they write things, all those different ways mean find the derivative. F prime or y prime or d dx or dy dx. Yeah, you just read this dy dx, derivative of y with respect to x. All that just means find the derivative. Okay, there were a few problems on your last assignment that you might have known the answer without doing that whole big limit formula. Like, remember a derivative is just a slope. So if I give you f of x and I say this is 3x plus 7, what's f prime of x? Okay, a derivative, remember it's just a slope. So what kind of problem is that?
Slope form.
Yeah, isn't this kind of like y equals mx plus b? So do you have to do that whole limit process to find the answer? What's the slope of this? 3. Yeah, the derivative of that problem is just 3. So the first easy shortcut is like linear equations like that. Yeah, linear equation. You know the slope, it's just 3. You can look at the problem, you're like, see, it's 3. Same thing with like, what about f of x equals 5? What kind of problem is that? If I graphed it, what kind of thing would that look like?
Straight lines.
Yeah, that'd be just a line like 1, 2, 3, 4, 5, here's 5. I knew what you meant. Horizontal line, just a flat line. What's the slope of that?
0.
F prime, so that's your derivative. Yeah, that's the slope of that's 0. So the first shortcut is like a constant like that, like 5. The derivative, they say the derivative with respect to x of, oh here, I want to put like bracket. Shoot, let me rewrite it. I don't want to be sloppy. Okay, d dx. The derivative of a constant, c, I just put c for constant, is always going to be 0. That's the first rule. Derivative of a constant always is going to equal 0. Just a quick little rule to you know, just focus in on that fact. And it's because a constant, like a number like 5, is just a flat line, like you just said, its slope's always 0. And think of that too when you're doing like the linear equations. Y equals mx plus b. You can just look at it. Oh yeah, I know the slope. It's just 3 on that one. Okay. Then we get into what's called the power rule. So derivative of a constant is always going to be 0. Then there's the power rule. This is when you have other functions with higher powers, like something like maybe like x to the 3rd power or x to the 4th power. Then you're going to use this power rule. So you take a problem, and it'll be like x to some power. The power rule is you take, to find the derivative of that, like to find f prime of x, the derivative. It's actually pretty easy. You take that little power, whatever it may be, it could be 3rd power, 4th power, whatever it is. You actually bring that in front. It's going to be n times x, nx, and then you subtract 1 from the power, and that's the derivative. This is the power rule. So, like if you have a function, we'll do one off to the side here. Like if you have a function like x to the 5th power, what's the derivative of that? What's f prime of that?
It's going to be 5x.
5x, yeah, the 5 comes in front, and you just subtract 1 from the power. You guys said it would be, yep, 4th power. 5 minus 1 would be 4th power. That's the derivative. That's easy. See, that's pretty simple. Let's try a little trickier one. Let's say you have some more examples with this power rule. Let's say you have a function, I'll just call it g of x, and let's say it is the cubed root of x. Okay, so I gave you this problem, and we're going to find the derivative of it using this power rule. So could you rewrite x to a power instead of in this box?
X to the 1/3 power.
Yeah, that is the same as x to the 1/3 power. Yeah, remember radical, like a 3rd root, that's the same as 1/3 power. Like next to the x is really like x to the 1st power. Remember, it's like a fraction thing, 1/3. The index number that's out front goes in the bottom of the fraction. So use this power rule to find the derivative. So the power rule, do the same thing like you just did on this one. It's a little different since it has a fraction, but what do you think your new g prime equation will be? G prime, your derivative, is going to be what? Starts with 1/3. Yep, bring the 1/3 in front, x. Now you have to take 1/3 minus 1. We have to figure out what 1/3 minus 1 is. Yeah, so it's 1/3 x to the negative 2/3.
Could you also write that as x to negative 2/3 over 3?
Well, they don't want to have, usually you don't want to have negative exponents in your final answer. So then they would put that down here to make it positive 2/3 power. 1 over 3 x to the 2/3. That's the final answer. See, like you've learned in previous math classes, you don't want to have negative exponents. So then they just move that to the denominator with the 3. Okay, let's try another one. Let's say you have y equals 1 over x to the, let's just do 1 over x to the 3rd. Sure, that sounds good. How are we going to find the derivative of that one? Well, this power rule doesn't have fractions. See, it's like that's not a fraction. The power rule starts with just something x to a power. So I don't want to have a fraction. Is there another way to rewrite this thing?
X to the 3/3 power.
Yeah, that's x to the negative 3rd power. Yeah, so you want to rewrite it so it's not a fraction anymore. Now you can do your power rule. Yeah, so the derivative, it'll be like y prime, equals, our derivative equals negative 3, and then what?
Over x to the 4th.
X to the negative 4th, yep. So then final answer, I heard it, yep, Austin over here. So the negative 3, that's fine. But see, we don't want to have a negative exponent, so you put over x to the positive fourth. You make it a fraction back again at the end. You put that in the denominator, so it's positive fourth power.
But isn't the negative 3 and the x multiplying towards each other, so that the same? Because like it's negative 3 times x to the negative.
But it's like 3 over 1. It's like negative 3 over 1 times that. Yeah, so the 3 has to stay in the top.
I was
Yep.
thinking that you'd be like 1 over negative 3 to the x to the 4th.
If they would have put a negative power on this, or if this would have been parentheses or something, then the 3 would have had to move. Yeah. I know there's like little trick stuff. So power rule. Okay, so what about something simple like, we'll squeeze one more in over here. What about y equals, like the one I had on the board, 3x plus 7. Now I'm starting with like putting like addition in here and stuff too. Well, you can still do this power rule. You can still do this power rule we just talked about. So the first part of the problem, isn't that 3x to the first power?
Yeah.
So think of the power rule on that. Ignore the 7 for a minute. Just think of the power rule on 3x to the first. You'd bring the first power over, right? 3 times 1 is 3, so it still is going to be 3. And then it'd be, you subtract 1 from the power. Well, what's 1 minus 1? 0. What's anything to the 0 power? 1. See, it's just 3. See, that's what I was trying to point out. This is like a linear equation. The derivative of that is just 3. Yeah, y prime equals 3. Because what's the derivative of 7? A constant. 0. So it's just the first part. It's just 3. I know, it's kind of weird. Okay, now let's get to a couple more difficult ones. There's a constant multiple rule. Constant multiple rule. Okay, so this is when you have, okay, this is just some like d dx. That means, okay, this is how you find the derivative. What if you have a constant times a function? Like what if you had like a number for c, like 5, and then some function like x to the 5th or something, or x to the 6th? Well, it's done the same way. It's like the constant times the f prime derivative. Oh yeah, that's fine. It's kind of, I know the notation, that's how they would write it in the book. Like, I know that's weird. You're like, what does that mean?
More English than that.
Yeah, it's like weird. So it's like when, so I'm saying it's like you have a c, a constant, and then you have some kind of function, f of x, like maybe you have x to a power. Like maybe you have x to the 6th power or something. How do you find the derivative of that? Well, it's the same way. Like we were talking about on the previous page, you bring that n to the front. So it'll be like c times n. C times n. That constant in the front just gets times by that power that you bring forward. And then we said you're going to subtract 1 from the power. That'd be how you, the process of how you do it. So let's try one. Let's say we had y equals 5x to the 3rd minus 2x squared minus 4. And you can do derivatives with addition problems and subtraction problems. You just look at each piece. Like, let's do the power rule on this. Then let's do the power rule on this. Let's just look at each piece one at a time. So even though there's a 5 in front, that 5, see, that's the constant. It still stays there. See, the c is still in the answer. And you just bring the power times the c. It's just times. So what do you think?
15.
Yeah, 5 times 3. It's going to be 15 x to what? Squared. So we did the power rule on the first part of the problem. Okay, now you look at the next part of the problem. Let's do the power rule, the same rule on this. What would we get?
4x.
Yeah, 4, and then 2 minus 1, yeah, that's just x, 4x, x to the first power. Okay? What's the derivative of just a plain number?
0.
Good job. So, derivative of a constant, that's what you were gone getting your ID. The derivative of a constant is always 0. So that one's just 0. So here's the answer. This is y prime. I put a prime, that's your derivative. That's the derivative. That's the shortcut.
That made that number 7 one easier.
Yeah. Okay, finally,
Did we just do number 7?
derivatives of, what about some trig functions?
What?
Derivative of sine and cosine. Let's do those last. Okay, these you just have to kind of memorize. There is a proof for these, but we're not gonna do the proof right now because we've done so many proofs with all those limits. There is a proof. It's in the book if you really want to see it. There's a proof to doing the limit f of x delta x
Like
and
the
all
full
that.
page kind?
Yeah.
No.
Okay, let's just learn it and just, you guys, basically you just got to memorize it. What's the derivative of sine? It's actually super easy. It is cosine.
Oh.
The derivative of sine is cosine.
Is a football the other way too?
Not quite. The derivative of cosine is negative sine. That one you have to remember, it's going to be negative sine. Derivative of sine is cosine. Derivative of cosine is negative sine. There is a proof for that, for how they got those,
No.
but it's the whole limit thing. It's in the book if you ever wanted to look at it.
I don't think I can.
No.
But yeah, like if you were in college, they might be like, you're going to have to prove this, that this equals this.
Let's not.
We might do some proofs later in the year with those, but yeah, they're just like in the book. I know I saw them. I'll find them. Constant multiple rule. Here it is. Here's the proof. Here is the proof of the first rule that derivative of sine equals cosine. Because they would do sine of x plus delta x minus sine of x all over delta x. They would do that limit thing we learned. And then that's like sine of a plus b. You learned it was like sine a cosine b plus cosine a sine b. It was like a sum rule. It was like a rule you learned in trig. And then they I don't know, you have to look at it and see what they did next. It looks like they factored out a sine here
To make it 1
and made it 1 minus cosine there. It's weird. You gotta like really study it over. And they did a whole proof and they got down to the bottom that the derivative of sine is cosine.
All that work for 3 letters.
Yeah, so see, we don't need to do the proof right now. It's just remember derivative of sine's cosine, derivative of cosine's negative sine. Yeah, it's all here. It's just studying over like how'd they get that? It's like, oh weird, they did this. They have cosine, sine. Oh yeah, here they put those together and factored out a sine. It's interesting. You got to study these over. It's like, how did this work? Oh, then they use the special trig limit. Remember the sine? A limit of sine over sine delta x over delta x, that equals 1. And this is the other special trig limit that we learned. And then they had cosine left. Yeah. So they use special trig limits in there, and you just got to like study like how did they do that? All right. So we know the shortcuts now. So now